Okay, now we are going to do some problem solving, and this involves particular equations for logarithmic functions. So example number 1, suppose that f is a logarithmic function with values f of 3 is equal to 7 and f of 6 is equal to 10. A, without finding the particular equation, find f of 12 and f of 24. Letter B, find the particular equation algebraically using natural logarithms. And letter C, confirm that your equation gives the value of f of 24 found in part A. So we start with letter A. And letter A wants us to find the function when x is equal to 12 and when x is equal to 24. So what excites us here is that without even looking or without even finding the particular equation for this logarithmic function, we can still be able to find f of 12 and f of 24. Of course, by using some techniques. And these techniques involves creating tabular representations for the x values and the y values for our logarithmic functions. And of course, the property that is adherent to this finding of the values would be the multiply-add property, right? So in this case, this would be my x value and the other would be my y value. Okay, so we have the given f of 3, which is equal to 7, and f of 6, which is equal to 10. So those are the two sets of points that are given in this logarithmic function. So the first one involves our first value is when x is equal to 3, okay? And the second is when x is equal to 6. So when x is equal to 3, our y becomes 7. And when x is equal to 6, our y is equal to 10. And now we have to look for specific patterns. For the x values, notice that this is multiplied by 2. Okay? Therefore, the corresponding cells would also have to be found by multiplying the previous value of x by 2. So we multiply 6 by 2. That will give us 12, right? So this becomes 12. And multiply 12 by 2 gives us 24. And multiplying 24 by 2 gives us 48. So we have 12, 24, and the last would be 48. Of course, we have found these x values using the multiplication property. Okay, multiplying all of the x values by 2. Now on the other side, if this would be a logarithmic function, then we have to find a specific pattern which indicates an addition, okay? Because this should be multiplication, and this should be addition, okay? In this side is addition, on this side is multiplication. So 7 going to 10 is actually an addition of 3. Therefore, we are going to add 3 to the succeeding cells. So the y values now begins from 7, going to 10, and then going to 13, and then going to, I'm not supposed to write 13 in there. Okay, so plus 3, okay. So we will have 10 plus 3 is equal to 13, and then when you add 3 again to 13, that becomes 16, and adding 3 to 16 again becomes 19. Okay, so now we are satisfied, or rather we have satisfied letter A by getting or by obtaining f of 12 and f of 24 without looking for the particular equation, or without writing the particular equation. And our answers for f of 12 is 13. Okay, so our value for f of 12 is 13, and the value for f of 24 is 16. Okay, so noting that in reading, we have f of 12 is equal to 13, and f of 24 is equal to 16. Okay, so that's the answer for letter A. Letter B, find the particular equation algebraically using natural logarithms. So we are going to use natural log to find the particular equation for this logarithmic function defined by x 3 and 6 and y values 7 to 10. We have to stick to the original points given. So since we already have the points, so let's do it here. Okay, and what are our points? Our points are, point 1 is 3 and 7, and point 2 is equal to 6 and 10. Okay, so 6 and 10. And what is the standard equation for a logarithmic function in terms of the natural logarithms? So f of x is equal to a plus ln of, or b, a plus b ln of x. Okay, so we have, what are the givens that we have? This f of x here is actually y, so rephrasing this equation into y in terms of x, so a plus b ln of x. And we're going to get the first equation. So the first equation will give us 7 is equal to a plus b ln of 3, and the second equation will give us 10 is equal to a plus b ln of 6. So these are our equations. This is equation number 1, and this is equation number 2. Okay, how do we solve for a and b? Okay, that is the challenge. Notice by using subtraction property for algebra, so we subtract 1 from 2. So let's try doing 2 minus 1. Okay, so let's try doing 2 minus 1. And how do you do, or how do you choose which one to subtract, or which one to add, or which what method to be used? In this case, you know, we have two unknowns. We have a and b, and for you to be able to cancel at least one of the unknowns, then there are specific techniques that you can use. If you have this binomial term here, then most likely the one you are going to use is the subtraction property for the algebra. Okay, and you could cancel one of the unknown terms and solve the other term, and then after that substitute the value of the term that you solved, and then substitute it to either of the given equations. So in this case, 2 minus 1 means that we are subtracting the first equation from the second equation. So 10 minus 7 becomes 3, and a minus a would be cancelled. Okay, so we already got rid of the a, and in this case we have b ln of 6 minus b ln of 3. You cannot cancel them directly because they have these terms have their specific what do you call this? They are not separated by the term itself, so they are attached to each other. So in this case, what we can do is to get the factor. So get the common factor from the right side. So b could be taken out, and this will yield ln of 6 minus ln of 3, and this will give me a value of b which is equal to 3 all over ln of 6 minus ln of 3. And using our calculator here, so using a scientific calculator in particular, we have 3 divided by, what is ln of 6? Ln of 6 is equal to 1.7917 minus ln of 3 is equal to, ln of 3 is equal to 1.0986. Okay, so our b then is equal to 3 all over ln of 6 minus ln of 3. So this will give us a value which is equal to 4.32. Okay, I have to clarify my 3. So 4.3280. Okay, so this is the value of my b. Okay, so the next thing that I'm going to do is to substitute this value of b to any of the equations given, okay, to the equations that we formed. Okay, so in this case, I want to equation 1. Okay, so we would like to use equation 1. So I have 7 is equal to a plus b ln of 3. So you have a natural logarithm of 3 multiplied by b and added to a. And my b is equal to 4.3280 ln of 3. So my a then would be equal to, so let us do that. We have 4.3280, and with a series of decimals, okay, ln of 3, okay. So we have 4. So let me compute it with my calculator, okay. That's okay, and we multiply this value to ln of 3, so times ln of 3, okay, and subtracting this value from 7, so minus 7, will give me 2.2451. So 2451. Okay, that's the value of my A. Therefore, the equation for my logarithmic function would then be equal to, what is my equation? We have f of x is equal to, okay, equal to, my A is 2.2451 and my B is equal to, okay, let me put this in a better position. Okay, let me enlarge this box here. Okay, so my f of x now is equal to 2.2451 plus b, and my b is 4.3280 ln of x. So this is my logarithmic function. Okay, and what else? Okay, so that's my logarithmic function. So by calculator, okay, by calculator now we could find the value of our f of 24 as in C. So in C we are asked to confirm that our equation gives the value of f24 in part A. So we found here in part A that f of 24 is 16, and we're going to confirm it using this equation. So we're going to find our f of 24 here. So f of 24, and this is letter C. Okay, so f of 24 is equal to 2.2451. Let's say we want to round this off to the nearest tenth of the thousands. Okay, so plus 4.3280 ln of 24, and the value that we could find here is, so let's check our calculator, 2.2451 plus 4.3280 ln of 24, and that will give me 15.9999. Okay, 15.999 blah blah blah. Okay, and of course when we round this off to the nearest whole number, our f of 12 or 24, I'm sorry, not 12, so our f of 24 is equal to 16. So therefore we have confirmed that the value of our f of 24 gives 20 or 16, gives 16 as written here using the tabular method. Okay, so that's the answer for this problem, example number 1. Let's go to another example. And we're going to continue this example on the next video. So stay tuned and have a nice day.